All right, welcome back to our show tonight.
Hey guys, welcome back to our channel.
Ooh, my goodness. We got some probability, probably. All right, so 11.5 and 11.6 are going to be paper notes. You have them in front of you right now. We will be taking a test over those paper notes. But then there's another section coming to a theater near you. It's a digital section. Everybody will be digital on that particular section because I couldn't find any really good notes that I liked. They were either way complicated or they asked way too many questions that I didn't want to get into. So we're all going to do some digital questions together on that. And we are going to do that together in class. And that will be included in your test. And what I mean by that is, when you get to the actual test, you'll have basically a third of the test already done. Okay? The only thing that we will actually be testing on in class will be the paper stuff, which you and I are doing right now. Because I promised you that your tests would all be over the notes that we do. So this digital section, which will be coming to a theater near you, is not going to be a part of a paper test. Okay? In fact, this section right here won't even be on your final exam. 5 and 6 will be, but not section 7 on your final exam for that chapter. Does that somewhat make sense? Okay, I'm sure I'll have to explain that later, especially to the two people who aren't here. Okay, so independent events do not affect. That's affect with an A. Because it's a verb. Well, A is the verb, E is the noun. So you have to think, is it? Right? So that is an action. That's a verb. No, that's A. Right? This is the effect it had on me. Effect. I always have to think about it too. Anyway. Difference between affect and effect. Okay. So independent events do not affect each other. This goes to something called the multiplication counting principle, which I should probably get you a little bit better definition of so that it's not so mysterious. But you'll see it show up in this particular problem here in a second. When they use this notation right here, P, they mean probability of A and B happening. I think it's 2 P's and 1 N, but double consonants kill me. Probability of A and B happening together. Or at the same time. That's what this notation means, probability of A and B. Now, it's actually pretty easy. The probability of A and B, when they are independent, this is only when they're independent. You cannot use this in other situations. The probability of A and B would be the probability of A times the probability of B. It's a very, very simple formula. And here we have the two parts. Probability of A, probability of B. I know. Sound like I'm in a cartoon, don't I? Hey, boo-boo. Oh, you guys, that's an old cartoon. You guys wouldn't even know that one. So, what is 1/5 times 3/7? Please multiply across. Do not cross multiply. Because it's not a proportion. When you're multiplying fractions, you multiply straight across the top and straight across the bottom. So do you know 1 times 3? How about 5 times 7? So the answer to my question is 3/35. Now, if down deep inside you really feel like you have to give me a decimal, okay. I don't care. Doesn't bother me if you do. It's kind of funny when I turn on the video, you guys like go silent. That's funny. Well, you don't want to be like permanently going, oh my goodness, how in the world can they say that? I don't know. You know what we should do? I really should do this. I should get kids to take tests on Twitch. And then I get on there and commentate, like, oh my goodness, I can't believe they did that. That's, and be like, oh, nice job. Let's see, score. I'd be like a commentator. I should do that. Okay, next question. This phrase, mutually exclusive, which I will abbreviate. Yes, mutually exclusive, which is not the same thing that you are thinking of. Dating. Yes, we're mutually exclusive, right? Oh, you just abbreviate it because exclusive is too long? Okay, so I'm going to abbreviate it ME. It means two events can't happen together. Which is really good until you get married, and then never mind. You'll figure it out someday. Okay, I'm just saying. All right, now, what is the probability that two events can happen at the same time if it's impossible? It is 0. So when we say that two events are mutually exclusive, we are implying that they can't happen together, therefore their probability of happening at the same time is 0. But that's not what this question is asking me about. It's asking me about when one or the other will happen. Now, I'm wondering if you guys remember before break when we were doing Venn diagrams, and I drew a Venn diagram like this, and we called this C and this D, and there was an overlap in the middle. You guys remember a picture like that? A little bit. I mean, it was like science classes and math classes. I just did. Now, when you count everything in C and everything in D, how many times did you count the middle? You counted it twice. Is that true? Should we be allowed to count it twice? Or should we be allowed to only count it once? Once. That is true. We can't double count the middle. So the formula for probability of C or D looks like this. We'll take all of the probability of C and we will add all the probability of D, but we're going to subtract what they have in common. Because you can't count the middle twice. That's why we're subtracting it one time. Well, we got the probability of C. That's 3 over 7. Plus the probability of D. That's 4 over 7. Minus what they have in common, which is 0, right? It can't happen at the same time. So, if I add those two and subtract what's in the middle, what do I end up with? Talk to your neighbors right now. I'm going to pause for station identification. This is the All Algebra 2 Network.
Oh my gosh.
What? Okay, so what is 3 7s plus 4 7s minus 0? 7 over 7. That's true. Also known as 1. Or 100%. Now, I don't care which one of those answers you give me. If you said 7 over 7 or 1 or 100%, those are all the same. Does that make sense? Very inclusive. Wish I understood. Okay, now 3 and 4 just ask me to identify situations that are either independent or dependent events. Remember, dependent means they affect each other. And independent is no effect. Ooh, but the way I just said that, no effect. Oh my goodness. using it like this is a verb. They affect each other. And here I'm saying there's no effect. Whoa. Or you could say, does not affect. That is weird. Well, it depends on how we're using it, verb or noun. I'm telling you, I teach you all kinds of stuff in this class. Okay, so I rent a car. Rental car is selected at random. A hotel is selected at random. Does one depend on the other or not? Nope. Those are independent events. Pause for station identification. Under what condition would that change to dependent? Yeah, well, under what condition could we make that happen? If I decided to change my choice. Why? Because of my budget. So if we consider a budget, I actually don't have an infinite amount of money. Now, if I got an infinite amount of money, this is definitely independent. You thought I was rich? Well, someday I will be. Someday I will be. Keep those hopes high. I will. I will. Okay. Question 4. A pet is selected at random. The kind of food for that pet is selected at random. That's dependent because we're not buying fish food for horses. That would be a lot of fish flakes. If you got, dump truckloads of, fish flakes, you might be okay. We're not going to buy horse food for fish. No. We couldn't digest it. Okay. All right, now, number 5 goes back to question 1, so use your mad skills to figure it out. And I will come around the room and see if you get it right. Go. Oh. So you guys are right. Because they're independent, we can multiply these two things together. And most of you put 3 over 42. Would it also be okay if I put 1 over 14? What about if I put 0.071? What if I put 7.1%? Lots of choices, but if you want to stop with 3 over 42, be my guest. It works. A pet store has 11 puppies. You know what? Not every class has done that, but a couple classes. As soon as I got the word puppies, I heard that. But not every class. Not every class. Just a couple of them. I'm like, that's interesting, Okay? Including 2 poodles, 4 terriers, and 5 retrievers. Thank you very much. If Rebecca selects 1 puppy at random, now keep in mind, this is not normally how we select dogs. At random. Okay? Preferably not with a dart, because that would hurt the dog. Okay? Yes, that's in the video. The pet store replaces the puppy with a puppy of the same breed. So after Rebecca chooses, then they put another puppy of the same breed back in the litter. Or what? They have backup puppies, right. Okay, like backup dancers. Puppies. Okay. Then Aaron chooses a puppy at random. Find the probability that they both select a poodle. Okay, so we got these 2 events that are happening, and we've got Rebecca's choice and we've got Aaron's choice. Now, what's the probability that Rebecca chooses a poodle if she chooses at random? 2 out of 11 puppies. Now, if these things are dependent events, then that means the probability that Aaron chooses a poodle, well, if they're dependent, that means that there would be 1 poodle left and only 10 total puppies. Is that the situation we're in? No. How do you know that? Well, are there only 10 puppies? Well, how do you know that? Because of the backup puppies. Remember? The backup puppies. It says they replaced the puppies with a puppy of the same breed. Kind of. So we're not talking about a dependent situation. Okay? So what is the probability that Aaron chooses 2 out of 11 also, because we have another poodle has been added to the mix. And so now, Hunter, 2 times 2. Okay, I don't think you'll find it under that nail either. What's 2 times 2? Oh, okay, thanks. Well, there were 2 poodles and 11 total puppies. So we did 2 out of 11. Okay. These will be because they're doing the replacement. Now, if they had not replaced the puppy, like a lot of, pet stores probably wouldn't, like have the backup one sitting in the back going, oh, hey, right here, then we would have had a 1 out of 10 situation. Okay? It's kind of like those situations with decks of cards where they put the card back in the deck, or do they keep it out of the deck? Now, if I only knew 11 times 11, Wireman says 121. Oh my goodness. Okay, so if we choose puppies at random, which is not very likely, it will be 4 out of 121 that they both get a poodle. It's not real high if you're choosing at random, but most people don't pick their dogs that way. Oh yeah? Well, I like the poodle breed. We have a mini golden doodle. The reason they breed a poodle with so many other different dogs is because they don't shed. And it is nice not to have a dog that sheds. Okay, duly noted in the record of this video for the rest of time. Ooh, okay, definitely not getting one of those. Okay. It does? I think, quite honestly, I took a bike ride yesterday, sat outside and, watched it all get dark and then it get light again. So I think I got more sun yesterday. I probably got my head fried. It looked weird. It did look weird because I just looked straight out because there'll be a million pictures and videos. I don't need to look up at the sun. I can look at everything else. And it just was weird to see everything get dark and get light again. But last night it also got dark too. So there was that. What? Why are you looking at dogs? Chiweenie? Chihuahua mixed with what? Oh my goodness. That is... Okay, I do not like the looks of that dog. Yeah. It's like a Chihuahua. Okay, so in this particular question, they are talking about the sum. We're going to roll a pair of dice. So you and I are going to create a sample space. And this needs to be in your notes, so make sure you write this down. We're making a simple chart. So we're going to list out the options for die number 1 and then die number 2 across the top. So it'll look something like this to start with. If we roll a 1 and a 1, commonly referred to in the casino world as snake eyes, for obvious reasons, what's the sum of 1 plus 1? 2. And if we roll a 1 and a 2, that'd be a 3, and a 1 and a 3, that'd be 4, and a 5, and a 6, and a 7. There's your top row. Well, guess what? If we get a 2 on the first die and a 1 on the second die, we get a 3 and a 4 and a 5 and a 6 and a 7. So column 1 and row 1 look pretty much the same. Well, 2 and a 2, that'd be a 4, 5, 6, 7, 8. 5, 6, 7, 8. 3 and a 3 would be 6, 7, 8, 9, 7, 8, 9, because he was hungry. You know, not many people have laughed at that joke today. I mean, seriously. I mean, it's like, plus my backup laughers. Where were you? 4 and 4, there was an 8. 9 and a 10, 9 and a 10, we had a 10, an 11, an 11, and lastly a 12. How many total outcomes are there in this chart? Remember, this chart is a 6 by 6. How many outcomes are there? Is what? I thought you said it was just the 7s we were struggling with. Nice. All right. There's 36 outcomes. How many of them are 2? How many of the 36 is a sum of 2? Right up there, that's 1, right? Do you think if you bet money on that at a casino, you would win more money because it's less likely to happen? Well, I'm just saying, let's say you win, and you put money on that, would you win more money? Yes, because it's not likely to happen. If you bet on 7, it's the most likely to happen, so they don't pay you as much. Those are called payouts. And the payouts for currently or... You know what's interesting with people who are very wealthy? Some of them struggle very much to keep, and so they like have to go out on tour and do more and more and more stuff. I mean, I'm not saying all of them are done with their money, but some of them are, and then they're in big trouble. It is crazy. So out of those 36 choices, how many of them have a sum which is odd? How many of them have a sum which is odd? I'm circling them in blue right now. How many of them have a sum which is odd? Anybody count how many there are out of the 36? 18. Now, for those of you who don't know, that would be 1/2. But hopefully you all know that. What is the probability that the numbers are the same? That would be rolling a 1 and a 1, or a 2 and a 2, or a 3 and a 3, 4 and a 4, 5 and a 5, 6 and a 6. How many of the 36 options are in that group? I circled them in red. 6 of them. Now, we just did that for kicks and giggles because they didn't ask me what the individual probabilities were. What did they ask me? State whether the events are mutually exclusive. Can they happen at the same time? Do you see any options that I have circled in red and blue that overlap each other? None. Since there's no overlap, that means, yes, they are mutually exclusive. So we're getting rid of choice A and D. We're focusing on these 2 choices. Please make your selection based upon the reason that you see. We'll see what